Meanwhile, in our universe.
Wait a minute! Who are you?
Huh? Huh?
I can buy myself flowers.
Huh?
Good morning, everyone. Today, we are excited to report. Good morning, everyone. Today, we are excited to report on a fascinating aspect of the seed plants angiosperms. These flowering plants, found abundantly in our surroundings, play a crucial role in our ecosystem. Join us as we delve into the diverse world of the angiosperms, exploring their classifications, unique features, and the essential roles they play in shaping our environment around us. Angiosperms are a second kind of true seed-bearing plants called spermatophytes, and they are also known as the flowering plants. Angiosperms are classified together in a single division, the Magnoliophyta, often called the Angiospermophyta. Angiosperms are the most advanced group of plants or the most derived. They are called the peak of plant evolution. The group is named for having flowers, a significant synapomorphy that unites all angiosperms and separates them from other clades.
Angiosperms or flowering plants derive their name from their distinct reproductive structure, the flowers, which serve as a key-defining characteristics. Many angiosperms have evolved intricate relationships with pollinators such as bees, butterflies, and birds, ensuring efficient transfer of pollen and enhancing reproductive success. Additionally, the development of fruits such as a result of successful pollination aids in seed dispersal, often involving animals. Angiosperms also employ diverse defense mechanisms against herbivores, adapting to their environment. These defenses may include chemical compounds that deter herbivores, thorns or spines for physical protection, and even symbiotic relationships with predatory insects for pest control.
Angiosperms are varied groups showing off lots of different shapes and sizes. They are good in living in different places and have clever ways to adapt. However, it is essential to remember that being an angiosperm doesn't mean a plant is fancier than others. Evolution is like a puzzle, where pieces fit in all sorts of ways, and it's not always a straightforward journey. So, angiosperms are diverse and interesting, but not necessarily more advanced than other plants. Angiosperms or flowering plants have fascinating reproductive features that set them apart. One distinctive trait is the closed carpel, a structure resembling a protective house for its seeds. This closed carpel offers a sheltered environment, safeguarding the seeds during the development in terms of fertilization. Angiosperms showcase a unique process known as double fertilization. Unlike other plants, which typically have a single fertilization event, angiosperms manage two fertilization active simultaneously. This dual approach enhances their efficiency in seed reproduction and contributes to the successful growth of new plants. The closed carpel and double fertilization represent specialized adaptations that have evolved in angiosperms over time. These features play a crucial role in the reproductive success of flowering plants, ensuring the protection and efficient development of seeds, ultimately supporting the continuation of their species.
Angiosperms or flowering plants are an ever-changing diverse group. They continue to evolve with different species developing unique traits. Some have specialized characteristics like succulents where they store water in their tissues, making them juicy. Others have adopted a parasitic lifestyle, relying on other plants for nutrients. Additionally, angiosperms showcase a variety of leaf adaptations to cope with different environments from deserts to rainforests. The ongoing evolution within various angiosperms groups reflects a dynamic process of adaptation and diversification. It's like a continuous change of story with different species finding innovative ways to survive and thrive. So angiosperms are not a static bunch. They're constantly exploring new strategies for growth and resilience.
The classification of angiosperms or flowering plants is primarily based on distinguishing features such as the number of cotyledons, leaf venation patterns, floral arrangement, and stem characteristics. Angiosperms are broadly categorized into two main groups, the monocots and the eudicots. Monocots exhibit characteristics like having a single cotyledon in their embryos, leaves with parallel venation, and floral parts typically arranged in multiple of three. Examples of monocots includes grasses, lilies, and orchids. On the other hand, eudicots are identified by having two cotyledons in their embryos, leaves often displaying a reticulate venation, and floral parts usually in multiple or 4 or 5. Roses, sunflowers, and beans are common examples of eudicots. Beyond these well-known classifications, there exists a category known as basal angiosperms, which includes species like Amberella, Astrobilaealis, and Nymphaealis. These plants, while sharing some characteristics with both monocots and eudicots, represent unique evolutionary branches. Basal angiosperms diverged early in the evolutionary history of flowering plants, adding complexity to overall classification. The classification system provides a fundamental framework for understanding the diversity and evolutionary relationship among angiosperms. Through ongoing research may lead to refinements and further insights into their taxonomy.
To sum it up, flowering plants, also known as angiosperms, stand out due to their distinctive features like flowers and protective structures for seeds. Their unique two-step fertilization process enhances seed production efficiency, while not inherently superior angiosperms showcase diversity, adapting to different environments with varied survival strategies. Scientists classify them into groups like monocots and eudicots, based on features such as leaf patterns and floral arrangements, providing a structured understanding of their diversity. Ongoing research may refine our knowledge of their taxonomy, contributing to a deeper understanding of their evolutionary relationships.
Hey, watch it!
Cherry bombs away.
Yeah, that's real nice, Mia. Lovely. At least we know you'll have a nice orchard of cherry trees when you're done with all your pit spitting.
Aw, come on. I was gonna pick 'em up later.
Actually, you should leave them. Help out the life cycle a bit.
That's me, helping out the life cycle.
Seriously, you know those pits are seeds, right? Cherry trees are angiosperms.
I know the pits are seeds, but what's an angiosperm?
An angiosperm is a plant that produces seeds inside a fruit.
Then there must be lots of angiosperms around.
Most plants in the world are angiosperms. Those tulips and lilies in the garden, that oak tree, those roses, all angiosperms. There are two different kinds of angiosperms, monocots and dicots.
And a cherry tree is?
A cherry tree is a dicot. Dicots have two seed leaves, and their veins are branched. A dicot's vascular system is in rings, like the rings you see in a tree, and the petals on their flowers come in multiples of 5.
Hey, you're right. What about monocots?
Well, the tulips are monocots. When they start to grow, they have one seed leaf. Their long leaves have parallel veins, and their petals come in multiples of 3. They don't have rings like tree trunks because their vascular system is scattered in bundles.
Cherry trees are dicots, tulips are monocots. Both are angiosperms.
Right. Angiosperms have flowers and fruit that help make and protect their seeds. Those pits you're spitting came from cherry blossoms. When the cherry blossoms on the tree were pollinated, a seed began to grow inside the ovary, which became the fruit that formed to protect the seed.
So by eating the fruit and spitting out the seed,
you're giving the seed a chance to germinate or grow into a new plant again.
oh, that's what you meant by helping out the life cycle.
I think you're starting to get the picture.
Let's see. Angiosperms are plants that make seeds and flowers or fruit like this cherry. There are two kinds of angiosperms, monocots and dicots. When flowers of angiosperms are pollinated, they begin to form a seed. When the seed is planted, it will germinate and ta-da! A new plant will grow.
Well, you've got angiosperms down. Now if only the spitting would stop.
Hey, somebody's got to help the life cycle.